computer, share the screen. And let me get the slideshow going. All right. So what I want to talk to you today about is the Internet of Things and the cloud. So what I want to do is I want to go through just a brief explanation of what IoT is, and then I want to talk about the good side and the bad side of putting IoT in the cloud, because whether there's bad sides about it or good side, the thing is it's going in the cloud now. That's where most people put their analysis. That's where most of the cloud data is going. And so we have to look at whether or not this is what we have to do to make it worthwhile. Now, IoT's been around for a long time. It basically started when we started putting RFID tags on everything, in that we started having the first batch of sensors that went out that you could gather information about and start collecting all that information and aggregating it. And so this is nothing new. So the Internet of Things itself isn't new. It just means that there's technology out there where you can monitor and sometimes control physical objects that are out in the world, get information back from them, and all of this is communicated through networks. It could be Bluetooth connections to the actual devices themselves. It could then go over a wireless network. It eventually ends up on the internet, and it goes somewhere, right? And we're going to talk about the somewhere that it goes to. And then on the other side, information comes back, and some of these devices that are out there aren't just sensors. Some of them are actuators, which means that they can actually do things out in the world. And so we're going to look at how does all of this, where's it going? And the first thing with Internet of Things, and what are all the technologies that are rapidly coming to maturity for the Internet of Things. So this is the sort of realm of smart objects and communication. So this all depends on very fast communications, and as we see with 5G, and later 6G, we're getting faster and faster ways to speed up networks. We have all sorts of different types of networks out there. And so once objects out in the real world have this ability to sense and to communicate, then and to take commands, then we have the Internet of Things. So there's some really fun aspects of this. There was in Australia, they actually gave email addresses to trees, so people could actually speak to trees. And so they would have little plaques on them that would give you the email address, and so people could send, basically they ended up sending love letters to the trees. They did this at first because they wanted to be able to find out information about people and trees, but it ended up being even more popular than they thought it was going to be. So, one of the big frontiers for Internet of Things is what they call the smart home. And I'm sure a lot of us, I have too many smart devices in my house, but you have things like, oh, and it's funny, just on my watch right now, I got my Nest Home report. So it's my, my thermostat telling me things. So yeah, you have thermostats that are smart. They sense various things. They have programs running on them. They report the information back to some, in this, I have Nest, so it's reporting it back to Google. And then Google sends me things back to talk about what I'm doing, how much energy I'm using, light switches, all of your different utilities could come on this, and security systems, different sensors, cameras, all these sorts of things. TVs are being brought into it. There's all sorts of things, locks. I have all my doors are on smart locks, so you can control them even when you're nowhere around. You can do that, and we've controlled lights for a long time, but this is getting far more sophisticated about how you can control things in your house. And then this just goes up to the next level, which is cities. So you have the notion of smart cities. And with this, it comes down to transportation networks, energy networks, monitoring energy, monitoring movements of people, monitoring the various public transportation networks that are out there, and things like surveillance. Some of the things that people have used this for is that you can look at minimizing traffic in certain areas. And in fact, there's apps out there, so it's not even controlled by a city, but there's ones out there that will tell you where the busy parts are in the traffic, and you can go around them. It'll suggest other ways around them. You can try to limit waste and pollution by monitoring various systems, and energy systems can actually be far better because you could do things like lighting, and they do this in buildings now, but you could do it also in cities where if you don't need the lighting, you can reduce it. And there's lots of reasons why you might want to reduce use of lighting, but have the ability to have lighting when you want safety. And I've got I'm not going to show it now, but if you want to look at this YouTube link, it's about smart cities in Europe and about what they're doing. They do things for parking spaces, smart parking spaces. So you can where basically you can try to find a parking space by using an app that will sense whether a parking space is being used. And so if all sorts of different things that cities can put in to try to make their cities smart. And then the big power of this is not just that you've got all of this data coming in from sensors everywhere, but the fact that you can do data analytics on it. So the real power of Internet of Things is not the single instance, a single device producing a single stream of data. It's the aggregation of lots of devices producing lots of information and being able to aggregate that, study it, and learn from that. So you have, if you look at things like traffic patterns, people can use this if they're running a public transportation network, let's say buses, to look at where people actually are taking, how they're actually taking the buses, when they're taking them, where they're going, all that, to actually try to divert more resources to where it's needed. And in fact, this has even been done where you have companies that provide private transportation teaming up with cities that provide public transportation to be able to offer those two different things in a way that maximizes the amount of throughput that you can get into the system. So if you want to pay the cheapest fare, you'll go with the public transportation. But when that gets crowded and you're told that if you can afford to go in a more private way, but which is still efficient because it's going to be a small bus or something like that, you can actually pay a little bit more and take that. And that way the two services coordinate to get throughput. And so you actually can find it all sorts of things that you might not know. And you're getting that not from asking people what they do, but from actually observing what people do. So you, instead of having a survey where you're asking people how they travel on the bus network, you actually look and see what people really do, because the problem is that unless you actually really make observations, the other methods of acquiring information often can be faulty. People may not want to participate in a survey, or they may lie either on purpose or inadvertently. So you can take all of this and you can perform analytics on the information coming in. So where does all this information go? So you have the one part of Internet of Things are the devices that are out there. So there's now millions, billions of these devices. They have very small sensors on them. It's very cheap to put, now it's getting very cheap to put lots of different types of sensors on lots of different things. And so there's lots of things where sensors are being added. Yeah, and I see the comment where someone said, thank God we don't live under a totalitarian government. Actually, if you want to really see smart cities and totalitarian governments on steroids, the system is China, where they actually have, it's sort of like almost like a social media score that you have for things that you do in the world. So, you know, like various different things. If you go to various places, if you do certain things, if you post certain things, your score changes. And then that actually might affect your ability to buy a bus ticket or a plane ticket. It's quite, it's quite shocking the way they're using it, but it can be done. The thing is that a lot of this can be done right now, but we have that, the social credit system. It's terrible, the idea, but it's very doable. And of course, there's what they portray as the upside, where you get benefits if you score well on the social credit system, but it's a way of modifying behavior. And it's not just totalitarian systems that do it. Obviously, commercial enterprises want to manipulate your what you do as well. With IoT, it just expands the range of things that they can get, the information they can get. Now, when they get the information, it has to go somewhere, right? It's going out on the network. Where does it go? You can have systems where it'll go to a government or a corporation, and you know, they have their own server farm, or you can start looking at the public cloud system. So what are the benefits of structuring your IoT system, whatever it is, around the cloud? Well, the cloud already has the infrastructure that you need. You need to be able to analyze the data. You need to be able to get it in to the system, store it, analyze it, and then actually send messages out. All of that infrastructure already exists in the cloud. They didn't have to actually change very much to add IoT services to their system. Provide scalability. Like I said, the big potential for IoT is not doing it with one set of, like, you know, your personal devices, even though you might do that. That's not the real potential. The real potential is getting millions or billions of people's information, or the information from billions of sensors, looking at that, looking for patterns, aggregating that information. The scalability for doing that already exists in the cloud. And because you have pay-as-you-go services for a lot of things, then you can actually start doing this economically, because you can adjust what you're paying to what you're doing. It provides the ability to aggregate all of this. This is the whole thing. In fact, and as we'll talk about in the final week, when we look at the future of the cloud, what you really want to do is you want to be able to grab this information very quickly from everywhere. And that's where edge computing gets very important, because that way the tentacles of the cloud are reaching closer and closer and closer to not just people, but to the devices. And obviously the cloud already has a lot of storage and analytical services out there. So in fact, almost everything that you needed for IoT, besides the devices and the actuators, is actually residing in the cloud at fairly affordable prices, particularly when you want to scale this, this service up. And so while this might not be that attractive for, let's say, automating your house, it is when you want to automate or look at let's say energy patterns in a whole community, and try to get people to lower their energy requirement, or if you're doing it in a city, or if you're doing it for a particular type of device, sort of thing. So it has a lot of benefits. So usually this comes into what's considered infrastructure as a service. There's two things that we're going to look at. You can have infrastructure as a service, and we'll also see you can have platform as a service. So with the infrastructure as a service, you're providing the means for accessing your sensors and actuators in the cloud. So this really means the networking that you're trying to get. So you're actually trying to hook the sensors and actuators to the cloud. And so it's really giving you access control to your resources. And it's really a gateway to the pay-as-you-go services. So this is basically the bare bones. This is setting up the actual connection. And so if you have all the other, like you have everything else that you need, you could just use this part of the cloud to get your IoT going. You could also look at the platform as a service model for the IoT and clouds. This is probably right now the most widespread model, because the platforms have gone crazy for actually providing lots of functionality for IoT. So most of the public clouds, plus some specific public clouds that are for IoT, come with a range of tools and environments that will allow you to develop the applications for IoT, deploy these various IoT functions efficiently and effectively in a cloud environment. And their main characteristic is that they're really centering this around data. It's not so much the hardware. So the infrastructure as a service is really concentrating on how do you connect the hardware on the cloud side, the hardware on the IoT side. Whereas platform as a service is saying, how are you manipulating all this data that's coming in? When you use these platforms, it does all the infrastructure connections, and you're just really manipulating the data. And then you can look at software as a service. And these are services where you can access complete IoT-based software systems through the cloud. You can do it on demand, pay as you go. It's basically hiding the sensors and the IoT devices, the actuators, from you. It's now being called sensing as a service. So it's really on-demand access to a bunch of sensors out there. And a lot of these are built on top of the platform as a service infrastructure. But the thing is, what clouds are doing now is that they're layering this. If you want just the bare bones, you have the infrastructure, you can move up to platform, and then you can move up to even something that's far more abstract, which is software as a service, or just sensing as a service. Now, what I want to talk about is that it seems to make perfect sense that you would put the analytical side, the storage side, in the cloud, whichever cloud you're going to use, whether you're using a public cloud or you're going to use some of the public but specialized IoT clouds, whatever, maybe even a private cloud, makes sense. But there's lots of things that can cause some conflicts. And a lot of it comes down to the difference in the models between the cloud and how people use the cloud and IoT. So some conflicts, cost. Cloud is sold as being fairly inexpensive, particularly in terms of availability and performance. So, I mean, you get to choose how much you pay for these services. So you can get something that has very high performance and you spend more money, or you can accept that you don't need that high performance and you can pay less. And a lot of the services are pay as you go, so you can expand up, but you don't have to pay when you're not using it. IoT systems, and I'm not talking about a single device, but IoT systems are expensive in two aspects. They're expensive to develop. Even though the actual hardware itself can be very cheap, the whole infrastructure, the whole system for managing IoT devices is not that straightforward. And part of this is because you are always going to have three components to this. You're going to have the hardware itself and the sensing and the actuators and everything like that. You're going to have that. And you're going to have some form of networking. And in fact, you're going to be moving sometimes between 2 or 3 different types of networking that you need. And then you've got to actually get them out there in the field. So yes, you can have the idea that, you know, you're putting in the Nest thermostat and that's one device in your house. But if we look at how IoT is used in, let's say, factories or in agriculture, that you may have thousands of devices that you have to deploy. And the deployment, the maintenance, the surveillance of these things it's expensive. It's extensive and it's expensive. And so you have to be aware of where the cost is in your system. It probably is not actually going to be initially in the cloud. Flexibility. If we look at the cloud, it's built around flexibility in that they're trying to put in as large a number of services as they can. And so if we go to any of the big, large public cloud platforms, there's hundreds of services. So it's very flexible. And they let you choose. So, you know, even if you're choosing a compute engine, there's lots of variation that you can choose. Now, there is the notion of vendor lock-in. So it's not infinitely flexible, but it is flexible within the cloud platform itself. IoT devices aren't flexible. What? Because they're hardware. Part of it's hardware. They don't change. You have less flexibility because they're built to do one thing, or a couple of things, but they're only going to do that thing. And so, and the same with networking. They're only going to connect and use a certain type of network. So the IoT devices themselves, over the lifetime of the device actually in deployment, is going to be fairly inflexible as to their functionality. And then there is the notion of location. So with the cloud, it's virtual. So it's this idea that, yes, the cloud data centers, server farms do actually have a location, and there is some aspect of location that does affect what's going on, and that's why edge computing is getting more of an issue. But you really are, in a way, your idea about this, it's on the internet, and it's like where it actually is not as relevant as other factors. I mean, there are things with this because you have the problem of legal aspects about where the server farms are. You do have the notion of the network accessibility, everything like that, but it's not a big deal. It's not what this is the first thing you think of when you think of cloud, is like, where's the actual center? And most time you can't even find out where it actually is. It's just a broad region. IoT devices are based on locality. And in fact, that's one of their major properties, is that they are affixed to a device. Now, either they're affixed to a location, maybe they're a temperature or humidity sensor that's put in a certain room of a house, or it's put in a field for agriculture, or it may be moving around because it's in a car or it's in a tractor, but it's not like it's generally moving on its own. And even with that location, even if it's moving, if it's in a car, it's still that car is the location. So there's always this physicality, and the physicality of IoT is not something that you can abstract away. There's always some aspect of IoT that's physical. And this is a conflict between the cloud, which has from its start tried to take away the physicality of where the computers actually are. Now, I want to look at some problems that we're going to have with IoT and the cloud. And I posted a very interesting article that's on CourseLink. It's called "The Cloud is Not Enough: Saving IoT from the Cloud." And this is talking about the different issues. And I'm going to go over some of them, although I'm going to put my spin on some of what's there, particularly for the security and privacy aspect of it. But the thing is, these are all things that, while they're pointing this out about IoT because IoT has specific issues, some of these issues are things that you should be thinking about when you're designing. And so, I think you might have a design task. I think it's called the final exam, where you're trying to design a system that's in the cloud. You have to think of these things when you're designing things for the cloud. So the first potential problem that you can have is scalability. Now, that's one of the reasons why you go to the cloud, right? You're thinking, wait a minute, that was a positive of going to the cloud, was that it was scalable. But what we're talking about with IoT, we're not talking about a few devices. So even though there's obviously scalability is something they've thought about in cloud, the estimate is that in S3 for AWS, there's 1 trillion objects in there. But if you look at the estimate of the number of current IoT devices that are out there, and this is a few years old, it's 26 to 50 billion devices. And remember, many of these are producing continuous streams of data. And this is only getting bigger as it gets easier and easier to put these devices, sensors particularly, in houses, cities, cars, whatever, appliances. This is only going to get bigger. And it's not producing one piece of data, it's producing lots of pieces of data over a long period of time. And so this is very much a scaling problem. So, and when you think about it, so a lot of the trillion objects that are in S3 aren't constantly being moved around or maybe even accessed, whereas the IoT devices, the devices themselves are a lot of times setting up a continuous relationship with the cloud, because it's continuously sending data, or it can, and with some of them getting data back. Another thing, and this comes down to the whole notion of physicality, is latency. So the cloud is not in the physical world in that it's in the virtual world. So when you're doing things in the cloud, and you notice this too, that when you were doing some of the assignment, it would take longer to do something with the database, or take longer to set up a VM, depending on the time of day. So there is always lag in the system. And we're noticing it now. We see that now because of the pandemic, when we're all at home and we're all constantly using Zoom and on our computers doing whatever, and then on Netflix and everything like that, watching TV, well, watching videos. You have this notion of latency. There is a physicality that's there. The cloud itself, what we conceive of the cloud, what the cloud sold for, isn't really linked to the physicality as much as it should be. And so let's look at it. When you think about IoT, now it matters more. So if your upload to a database is a little bit slow, probably, that's annoying, but it doesn't go much past that. But let's say you have a temperature sensor, and the temperature sensor is controlling how hot or cold a particular room is, or equipment or whatever, or like maybe this is a greenhouse and you want to keep the plants from freezing to death or getting too hot. So the temperature sensor will measure the temperature. Then it has to send it to the cloud. So this might be a wireless or a Bluetooth connection to some sort of hub that then ships it out over the internet. That might be where it's going via wire, cable, or it might be going through a satellite connection that has all sorts of wonderful properties. Then it gets to the cloud. It does some sort of analysis, and the system detects there's unacceptable rise in temperature. Now it has to send a message once again over the internet. So it has to go through the networking in the cloud onto the internet, and then probably to some sort of wireless network or Bluetooth network to actually get to an actuator that turns a fan on. Okay, or adjust the temperature. And all of those things, particularly all the things I've got in here, italics, and this is usually where you touch the network, these are opportunities for unpredictable latencies. So you're gonna have the natural latency that comes with the device itself, its speed limits and everything like that. But as soon as you get into something that's shared, like either the internet or sometimes the networking within the cloud itself, you might not be able to predict what the latencies are. It may be, in theory, it's totally fast enough for what you want to do. In practice, it might depend on the time of day. It might depend on a whole bunch of things that will change the turnaround time for this. So theoretically, that sensing the temperature, analyzing it, and sending a message back to an actuator should happen very quickly. In practice, this is going to be inconsistent. So it's not that it's always slow or always fast. It's because it's the unpredictability of the latency, which is the issue. Bandwidth, we have this problem. Once again, anytime you go over networks, you are going to have problems. So with IoT devices, it depends on what network you're using. So with broadband networks, you typically have more downstream bandwidth than upstream bandwidth. So you have to worry about that, right? So the IoT devices are generally producing data for delivery to the cloud. And so they could saturate the upstream links bandwidth as the systems scale up. And so, and it depends on what kind of broadband network you're looking at as to what the difference is between upload and download. They can be tremendously different when we're looking at satellites. And even now they're looking at like the satellite networks that there's you know, where you're going to have hundreds or thousands of these little satellites and they're going to be doing, you know, internet in space. You know, Elon Musk is always talking about that. If you saw the last announcement from his company about this, it was basically, well, you have to pay a lot of money to get into the service. You're going to have to spend a fair bit of money per month. And oh, by the way, they're not going to even guarantee that some of the time it's basically not going to work some of the time. And they're not guaranteeing the speed. So it's like, there we go. That's wonderful. I guess it's better than what they have now in a lot of areas, particularly in our north and outside of cities, which is a whole lot of nothing with regards to internet. But it's certainly, there are physical issues about networking that you cannot ignore when you look at IoT. And so with this, you have this problem with guarantee of service, quality of service guarantees. And this is quite common in networking or networking applications where you want to talk about, are there going to be unacceptable latencies in the system, or is there going to be temporary unavailability of the system? And this is going to be really important when you think about putting a lot of devices and actuators out in the physical world that rely on analysis being done off-site, right? So in other words, you're not having it done right there and then getting it back from the cloud where it's done it, because there may be some applications out there that need real-time response or actions taken. So this could be if you're controlling a factory and you're controlling very dangerous processes. You don't want to have unpredictability about that. So you may, in fact, in those instances, you want it on site. You may say, you know what, can't do cloud, right? But then that means that some types of applications then that need aggregation or need information from a lot of different sources are going to have a hard time. We're also going to really run into this when we look at smart cars. And particularly if cars are going to have to go to the cloud for any of their information. And that's not beyond the realm of possibility because they're doing it now. And so lots of cars now are connected to in a way, connected to the internet. The problem is that if your car is dependent on that, that's not going to be good if all of a sudden it's temporarily unavailable. Like you're going to have to build the system so that the system can completely fail and you can recover, because you're never going to be able to say, if you go outside the car, right, then you're going to have some parts of the system that stay in the car all the time. They don't, like there's processing in the car that don't go outside to to any sort of network. So we have problems with quality of service guarantees. And there's just some applications that without that aren't worth pursuing. The other thing is durability management. And this is a little bit in the paper, if you look at it, you'll see that it's a more complex idea than some of the others, a little bit harder to figure out. And with this, it means that you can have data, particular data that's coming in from IoT can be, they call ephemeral, or it's durable. So ephemeral data means you don't care about saving it. You want to do something with it at the time, and then, you know, maybe you'll back it up, and maybe you just don't care, right? You know, like it just can go. Durable means that you want to actually hold it for a certain amount of time. So if you have ephemeral data, can you actually verify that the data is no longer there? And so that might be an issue. So it may be that you think, oh, ephemeral data would be easy. But then again, maybe not, because if there's any sort of security or privacy aspect to that data, how are you going to guarantee in this application that the data has been completely destroyed in the cloud? And in fact, when you look at some and investigate in how some things are done in cloud storage, one of the big sort of good things, selling points about cloud storage is that it backs itself up and replicates itself without you actually having to do anything. So this is this guarantee to you that your data is not just going to disappear. So even if they have a problem, you know, over in one server or in the data center, your data is somewhere and they can recover it. Well, there may be instances where you don't want that. You want, when it's gone, and you want it gone, and you want to know it's gone. So that can be a problem, because the cloud does a lot of things in the background that you aren't controlling. And so you might actually have to keep track of all of that and write that in to make sure that you actually turn all those things off that it's doing, if you can. Now for durable data, you have the other thing. Can you trust the fact that it's stored? Do you know that you actually have that those things, those mechanisms that are supposed to keep it there, do keep it there? And do you retain control over it all the time? And so with that, it might not be purely a technical issue. It may depend on where that data actually resides physically. So in a specific country. And when you have this notion that it may be replicating it and putting it in different locations for safety, did it ever go out of the region of control that you want? Maybe it goes into a data center that you don't actually have legal control over, or a government has control over it and you can't stop that. So because you're not really even asked. So for all of that, you may be trying to dig down through the levels of how storage actually works in the cloud system that you're using, and the type of storage that you're using. And what this really comes down to, and this is sort of the crux of the matter here, is that it's modeling it's modeling the worlds that we have. Sensors and actuators in IoT are physical devices in the physical world. So they have various demands on them that we don't think of when we think of computing in the cloud. So they have time and accuracy demands. They have all sorts of demands on them. They have power demands. They have connection to network. They have all sorts of demands on them that are physical, that you just can't wish away. The cloud itself is built on a model that's very abstract. And actually, as you go up sort of the levels in the different types of cloud platform that's presented to you, when you get to the top levels, when we're talking about, you know, software as a service or platforms as a service, you are now abstracted up to a level where you're not really as aware about the physical constraints of the system. So we often, I mean, it's a standard thing to do time travel in software. So the idea that you can undo actions. So, you know, like all software is like that. If you make a mistake or you do something that you didn't want, oh, I'll just hit the undo button. That doesn't happen in the real world. Undo is a real hard thing in the physical world, and it means something different. It's not like in virtual worlds. And so, especially once you start talking about actuators, the sensing is bad enough, the actuators are worse. Because with the actuator, once you've told it to do something, you have really two problems. One, you can't undo it. If it gets the signal, it's gotten the signal. You can do another command and try to undo the effect, but you aren't undoing the command. So you have that sort of, and that takes all sorts of things, because you're going to have something else that senses and tells you that the actuator actually did something. So you have that problem. Did it do it? I asked it to do it. Did it? I don't know. If I asked it to close a valve, did it? Right? I might have to be looking at something else, some other sensors to say, yeah, there's no water flow there now, so the valve must have closed. These are all really difficult things. And so when you're modeling this sort of thing, the two types of models, the real world models where you're worried about all of the things that really do happen and where there's no going back, there's no undos, and a world where you're quite used to this fact of, oh, I told it to open, so therefore the valve opened. No, maybe it didn't. And so you have to build the system to actually know that. So in fact, there's lots of examples of this in the real world, where when people went from analog systems where there was lots of sensing to digital systems where it was just like, hey, I get the command, you had lots of problems, like the radiation machine that AACL made that was killing people, the Therac. Part of its problem was they went from a system where you had actual physical analog devices stopping bad things from happening to digital ones where it was up to the programmer to actually figure things out, and they didn't. So you have this potential problem that you've got these two different types of models going on. And when you design these systems, you have to be proficient at both types of models. And a lot of times that's not a skill that a lot of people have. But the biggest thing that you'll see people talking about is this notion of privacy and security that when you go to the cloud with IoT that you have. So, and this is, it's going back to what we were discussing about the social credit system in China, where, you know, things are being collected all the time. And some of this is very sensitive data. And sometimes it's not really clear that people have consented or that people have knowledge that this is actually happening. And so IoT collects and the cloud analyzes and disseminates this information. And that can be a very powerful combination for creating a lot of bad things. And it also means that it may actually stop some things from being designed and built, because these are such hard issues and there's so much trust that has to be in this system. So I'm sure everybody's aware of what happened in Toronto with the Toronto waterfront and Google's Sidewalk Labs, where they wanted to have this amazing, wonderful, fun part of Toronto where you'd have all sorts of weird and wonderful things, but all sorts of data was going to be collected from people's phones without really explicit acknowledgement or consent. And so, you know, things like that, or things where we have security, where you have something that is controlling water and power distribution systems, smart cars, everything like this, security and privacy are huge issues. So, you know, as I said, you know, we know how it turned out with Sidewalk Labs and the Toronto waterfront. It didn't get built. They couldn't come to an agreement. There wasn't trust on either side about this going forward. There was particularly not trust on Toronto's side that they understood just how all of the devices and all of the systems were working. And this is, and where it was going. And actually, just a little small example of this is actually the Nest thermostat system, because it's collecting all sorts of information about how you're heating your house and what you're doing. Why does, you know, like, and this is wonderful, it gives me a report and everything like that, but why is Google, you know, we know Google is storing this information. What are they doing with it? We don't know, right? You know, like, it's just like, you've given permission for them to do that. And with a lot of devices, you have to give permission for this information to be sent out from your home, from your appliance to somewhere that a corporation has access to, with no explanation of why they want it. There's some good ideas or good things, like they may look at maintenance or they may make suggestions to you or help you out with that. But is that all they're doing? We don't know, right? There's no way to actually know that. Now, the other side to this is that there's, because of all the connections that we have here, because everything's going out over the internet, once it goes out on the internet, security is gone. Okay, and the only way you can achieve security in this world right now is not to send out anything on a network. Once something is networked, it's not secure. And so we have all these problems about if we connect devices and, the Internet of Things. It's the Internet of Things, right? It's internet. This is the problem, not things, it's the internet. So we have tons of insecurity. Even the primitive technologies that first came out, like RFID, Bluetooth, all of these things, anything that used network technologies, people have found a way to hack them, spoof them, jam them, all sorts of things. In fact, the first RFID tags, which were sort of the start for Internet of Things, had absolutely no security. They were designed totally without security, right? There was the whole thing. And a lot of these systems can be infected with viruses, and all sorts of things can happen to it. But security was usually an afterthought in all of these systems, and still is to a certain extent with a lot of systems, particularly that you use for your home. So, okay, the first thing that we have is just the notion of privacy. Okay, let's not even talk yet about security, about someone doing something malicious to you. That's just the passive sort of thing, that everything is giving out information. And you have this notion of opting in or opting out, and this is very controversial. So there's a lot of problems with opt-in, because often it's done in a draconian way where you have like 50 pages of legalese and you have to, at the end say, yes, I agree. Because if you don't agree, you don't get any service. So it's not like you lose just some part. It's not like they've proportioned out stuff and say, okay, you're using this thermostat and we're going to send some information so that we can do a report and help you manage your heating bills. And we're going to, and so do you agree to that? But we're also going to sell this to various companies that might, want to sell you various things and target you and all that. Do you agree to that? And you might say, no, I don't agree to that. They don't portion that out. It's just, do you agree or don't? And if you don't agree, you don't get any service, right? That's it. You've just said, this is a brick. I don't want to do anything because it doesn't have a non-internet functionality. You're connected or you're not. So the opt-in can be meaningless in a way, because either you opt in or you don't. And opting out is just as bad, because then there may not be that knowledge that, oh, I can say I don't want some of this done. I can actually say, don't sell my data here, or I don't agree to this. Sometimes there are those possibilities. People don't know about them, so they're just as draconian as they opt in. So the problem that you have is that we have this, in a way, the internet of stool pigeons. Everything that you're putting in your house now is talking about you. So your refrigerator is sending back information, the new ones. Your TV, any of your like your washing machine, any of those are all sending things back. And they may be saying, oh yeah, we're sending that so we can do maintenance, so we can like get ahead of something going wrong with your appliance. But do you know? And you can't, like I said, you can't opt out. If you don't want to send it back, there's bad things happen. And what happens when this is every device you have, every single thing, right? Is this an okay thing? Will it be managed properly? Will there be checks and balances put in there? There aren't yet. So, we have this problem, and it's like, yeah, we are then going to have to really worry about living in like totalitarian or authoritarian governments, having those types of things in our society, because once they can see everything you do, then they can start making up rules about what you do and what you can do and what you can't do. So there's good things, because maybe they can stop you from wasting energy or heat or something like that. But there's bad things where they can drive your behavior, and not in good ways. And so if you look at the different research that people have done about privacy concerns with IoT, you can see that they're in this one research study that 90% of devices collected at least one piece of personal information. Okay, so either the device could get it, or when you set something up in the cloud, or the mobile app that you use 90% of them were sending personal information back. 70% use unencrypted networks, which means that even if the company that is working this, like has sold you the device and is keeping the data, even if you trust them, other people could be listening in. 6 out of 10 devices provided user interface that were vulnerable to all sorts of different things, all sorts of cracking, weak credentials. That's usual. Like, they set up sometimes a login and password, and a lot of times it's an admin. Like there's all sorts of things that they don't actually set up anything really good because they know people, or they don't set up. They have it, but they don't set it up because they know people aren't that sophisticated. And so they don't want them to get frustrated because they can't set it up. They let them set it up, but they let it set it up insecurely or with lack of privacy. And so if you're connected to a network, anything that goes in the network, it's really hard to control. And it's also hard to distinguish between what could happen and what was meant to happen. So there was this case in California where in a preschool, the school required all the students to wear this little a shirt or jersey or whatever, and it had electronic trackers built into it, so basically the children could be tracked. So it's like putting a chip in your dog. Now, did they have a good reason for this? They didn't want to lose kids, which is good. You don't want, children running around or being abducted or anything like that. But the one bad thing about this is they didn't tell the parents before they did it. So you've got this invasiveness. And where let's say you say, I don't want my kid being tracked, it may be, and then someone said, now a hacker can know where your kids are. Yeah, that's right, because unless that system is perfect and you can't get in, not only can the school track kids, everybody might be able to track the kids. And if you say, I don't like that because I think, that it's too insecure, you might be looking for a new school, because they may say, out you go. This was a preschool, it was a paid school, so it was private. So yeah, that's bye. You kids can't come in here unless you agree. Baby cams are notorious for this. So they've had cases where there was hackers in Russia that would take control of the baby cams and be swearing and cursing at the babies for fun and doing all sorts of things and manipulating the camera and the sounds and all that. And that's just what you want when you have a baby cam. And it was all the usual thing. They did not set it up securely. There was no encryption. The credentials were weak, everything like this, because their whole idea was that, well, we'd rather you be able to use the device than to have to spend time reading the manual to set it up securely. So, some people got scared because all of a sudden there's, someone screaming at their baby in Russian. So, this doesn't make you feel secure. What really is amazing now is about cars. Can you actually trust your car? And this has been going on for a while. This is not just autonomous cars. A lot of times now, cars have black boxes. So you've got data recorders. It's like a black box from an airplane. They were put in so that they could help crash investigators find out what happened. And they were also, they could be useful that you could prove to an insurer that you were a good driver. So maybe your rates could be lower. The problem comes down to when will these be required? And how will insurance companies use them? And will this be real time? So is this after the fact, or is this are they going to try to strive for real time? One of the problems that you have is that there are cars now where the system, like everything's now controlled electronically. Cars can be deactivated. And a lot of times dealers like this because if the owner defaults on their payments or their loan, they may give the codes to deactivate the car to someone that's going to repossess the cars. The problem that you have is that you have a couple of things. One, what happens when there's a mistake? You were paying your loan and all of a sudden now your car doesn't work. Or even if you have defaulted, what happens if it's an emergency and you have to use that car? Or you know, even worse, if they can actually deactivate the car when it's running, because that would be incredibly dangerous. And because once again, these are on networks, then hackers can get in and deactivate your car. So we have all sorts of problems with this notion of being able to, you know, there's one in just recording, but if you've got the other side where you actually can do something based on some of these things, then you have a problem, because you have hacking, you have mistakes in implementation, you have all sorts of scenarios that you may not foresee. And so this is actually happening too. This thing about deactivating and having mistakes being made and people's cars basically being a big brick. The other thing is that your cars can be listening to you. We have the same problem with personal assistants like Siri and Alexa and all of these different things that are listening to you. Now, the thing is, how are they doing that? So with things like Alexa or Siri, or they have these, what is it, OnStar, these systems that are in various cars, you have to say something. Either you, in a car, you usually push a button, but as it gets more and more automated and it's done by voice, it's usually you have to say a phrase. But the thing is, it still has to be listening to you because it has to catch that phrase. So it's, you don't know how much when it's listening. And in fact, there's now court cases about when these devices were listening to you. And in cars, actually since 2003 in the US, the FBI has been able to listen in on conversations in cars that have these like OnStar systems, even without you pushing any button and without it showing you that it was listening. Now, they did this for mob-related investigations, but if we didn't trust, I mean, who doesn't trust the FBI? If you don't trust the government or government agencies, they say they're doing this just for criminal investigations, but the potential there is for them to listen to you all the time. So you have a problem. So you have a problem with in your car. You have a problem with things like Siri and Alexa. And in fact, now cars have Siri and Alexa activated in them. So all of this is getting more and more ubiquitous. Now, car hacking has been there for a long time, because at first it was just getting into your car. So, you know, as early as 2013, half of the vehicles stolen in London, and that's an amazing number of vehicles stolen, were hacked. So in other words, they electronically opened the doors and started the cars. So the thing is, a lot of these cars can be subverted through networking. And so the problem right now is that can they actually take control of your car? Well, they've actually shown that if they're a hacker very close to the car, in other words, another car very close to it, has been able to hack into some of these systems and do things with the braking and the steering, because all of that now is electronically controlled. It's still not that easy to do, and it's still not easy to do when you're far away from the car, but the more systems they put into cars, the more they connect it to the cloud, the more they connect it to networks, the easier it actually gets to hack into it. And if you think about this, the ultimate are things like self-driving or partially self-driving cars, where you don't actually want the car being taken over. I mean, they could take over cars, cause accidents. They could just do this inadvertently, goofing around with it, because 90% of hackers are just script kiddies who find something out there in the dark net or somewhere, and then they play around with it. Well, they may use it incorrectly, start turning off cars, or deactivating the steering or the brakes or something like that. Or now you can have suicide bombs without the bomber. You don't have to commit suicide, the car commits suicide. Again, you put anything in the car and then just have it go. So there's all sorts of things that you might think, oh, who would do that? If you can think it, someone will do it. And this makes it so that when you're designing these systems, because if you go to the cloud, you go over a network, anything that's got a network, you have to worry about all of this. So if you want to see more about what's out there for IoT, there's all sorts of systems out there that are being sold by AWS, Azure, and Google Cloud. And I've put some some links to that. And you can see, like if you go to the AWS one, you can see they've got things for device software, they've got connectivity services, they've got all their analytical services out that you can get. If you go over to Azure, they have all sorts of documentation on all the different things you can do with this. They've got everything set up so that you can manage your IoT solutions. And if you go to Google, they have their IoT core. They have all sorts of things that it attaches to, including AI, all those sorts of things, and all of this going over a network. Not saying that you would never, okay, we are going to use the cloud for IoT. That is just a fact. We are going to. So if you are doing that, you have to be very careful about what you do, particularly when things go the other way. If you're just sensing, maybe all you have to worry about is privacy, which is bad enough, and some aspects of security. Anytime it goes back the other way, where you're going to do something in the world, actually affect the world, now it gets hard. Now the design task is really, really, really hard. So if you're going to do that, and some of you will, you're going to be working with companies that do that, you really have to do a lot of analysis in your design. So that's, you know, a little look at that. We obviously don't have the ability to go and do that in the course. You can look at it and see what you might like. Maybe you've got some devices at home you want to connect up, but I'm not even sure your accounts will allow that. But if you get interested, yes, you can do it. But I just want you to be aware that this is a big, huge area of development, and can be really, what would I say? It can be scary. There's lots of potential for bad things to happen.